Hello, my name is Maxim Rudny. I'm a senior software engineer, and in this video we will talk about the high cost of the bugs. So, our plan for this lecture: we will talk about consequence of bugs in the software. We will take a look on 3 different samples, and we will talk about how much the error can cost for the company. Then we will talk about bug fixing efforts. After that, the advantage of early detection of bugs, and in the end, it's the rules we can follow to prevent bugs. And we have to remember that bugs are unavoidable, but what we can do. Let's start from samples. And the first one is Knight Capital case. Knight Capital Group was an American global financial service firm engaging in market making, electronic execution, and institutional sales and trading. In 2012, Knight was the largest trader in US equities with market shares of around 70% of the New York Stock Exchange. There was a deployment mistake. Code for algorithm verification on testing environment was executed on production. So when exchange was open, this algorithm started buying cells, and during 45 minutes it bought stocks for $4 billion. And after that, company should solve this issue somehow and have to sell these stocks. And this mistake was cost 450 millions of United States dollars and just 45 minutes of selling and buying stocks. After that, this company tried to solve the issue by buying these stocks again, and in the end, the whole company was bought by another company, and right now there is no such company on the market. So this was a very expensive bug for this company. Another case is Ariane 5 case. It's a European rocket program which was $7 billion. The first rocket was exploded. And why it was exploded? After a few seconds after when it started, there was an error in software when the 64-bit floating point number was converted to a 16-bit signed integer. This code wasn't wrapped in try-catch section, and the backup version of the code which should handle this problem was implemented in the same way, and software was turned off when I tried to convert this number, and the rocket was destroyed. So the loss of 500 million rocket made this possibly the most expensive computer bug in history. And the third sample which I want to show you, it's something that the cost of software defect can be measured in dollars. A pair of fatal crashes that claimed the lives of 346 people. There was a problem with Boeing 737 MAX, and the first crash was in October 2018. And after a few months there was another crash when the second plane was destroyed. And the problem was in outsourcing of software. Company bought the software in outsource company where developers were paid by $9 an hour. So the code wasn't tested well, and the cause of this bad written code was a crash of 2 planes with this death. Bug fixing efforts. What we need to fix a bug. So when bug was discovered during the testing, we need to spend a lot of time for reproduce this bug. After that, we register this bug and need assign to developer this bug. When we assigned, we need to discuss what was wrong and how we can solve the bug. And after that, it takes some time for fixing. So from my experience, it takes a lot of time for all these steps to register bug, reproduce it, especially reproducing, understand what's wrong, how it should be fixed. After that, we need to switch the context, switch to another task, or from another task, try to fix these bugs, and after that we need to double test it, verify, and close. So all these steps require a lot of time. Also, we need to remember that fixing familiar code is much more easier than fixing unfamiliar code. So if we work with code, we know how it works, and it's much easier to solve the problem in code we know. But in code which was developed a few weeks, months, a year ago, takes more time. So we need to remember that fixing a bug today is cheaper than fixing this bug tomorrow. And here we can check that during software development life cycle, on each stage it takes some time. So during implementation stage, fixing the bug can take 5 times more efforts than on design stage, and at the same time maintenance, when you will find this bug on the maintenance stage, it can take 100 times more effort to solve the problem than during design. So the latest time when you discover and you try to fix this bug, it will take more time and effort, and it will take additional money. We can't avoid bugs, it's impossible to write ideal code, but what we need to remember that fixing a bug is expensive, and we need to do everything to prevent bugs. So how can we do? There are a lot of steps and rules we can follow. For example, we can write unit tests, we can create a code convention and try to follow this convention. Also, there are tools for static code analysis and practices such as continuous integration and continuous delivery, which help us to do the best what we can and write much more cleaner code. That's why we have to use best practices and tools and try to do the best what we can.